Welcome video on function compositions as well as other operations, combining functions with addition or subtraction or multiplication. Mostly this will be about compositions. So we have two graphs that are given, function f here and function g. And we're going to concentrate mainly on these red points as we're doing this. And then we'll just do a sketch of the curve for our question that asked us for a sketch. So starting off with just two computations before we get into a sketch. Here we have a composition f composed with g and at the input of -1. I will rewrite this as, I'll use black. I will rewrite this as f of g of -1. So looking at -1 is the x value inside of function g. So we're going to look at function g. We're going to locate -1 on the x-axis. Here it is. We're going to find the y value for this x -1, which is up here. So the output is 3. So we have so far here f of 3. So now what we want to do is find the final output if the input is 3 inside of function f. So here's function f. Locate x is 3 over here. Go up to the graph, and the final output is again a 3. So that's an example of composition at a particular point. Let's do a sum at a particular point. So what we want to do is we want to add the outputs at the same input of 2 for both of them. In other words, this could be written as f of 2 plus g of 2. So f of 2, you locate the output when x is 2 in the function f. And you actually get 2 again. The output is 2. Plus g of 2, you go down to the graph and you get -3. So final answer is -1. So now let's do a rough sketch of g subtract f. What we want to do is subtract the outputs for the same x. We cannot just do it for random x's, it has to be for the same corresponding x. So we'll go through point by point. Let me use a highlighter. We're going to concentrate on x being -3 first of all. So we're going to look at what is going to be the result if x is -3. What would be our new output of these two functions subtracted? Now watch the order. It's function g subtract function f output. So function g output of this value is -2. We're going to subtract -2 with +1. So final result is -3. So this is -2 subtract 1. So this is function g of -3 minus f of -3. That's the result we record as our final point. So once I have all the points, I'll plot them afterwards, okay? So our next value is, I'll highlight it again. The next one we're going to concentrate on is x being -2. So we're looking for this new output here. What to record here if x is -2. Again, we want to subtract the output g minus the output of f. So output of g is 0. Output of f is -1. So it's as if we have, as rough work, 0 subtract -1. So final output here is 1. And I'll go through the other points a little bit faster. So now we're going through and looking for the input of 0 and finding the new output if the input is 0. So we're looking to subtract g of 0 minus f of 0 and record it here. So g of 0 is 2. F of 0 is -2. So 2 subtract -2 is 4. Next point is 1 as an x value, so output at 1. So g output is -1. Subtract 0. So just -1. Next one is a value of 2. So output here is -3. Subtract 2. So -5. And one more. at 3. Output is 1. And then here output is 3. So 1 minus 3 is negative 2. So all I'm going to do is plot these points roughly and connect them with a shape. It's not going to be perfect shape, but it gives us an idea how this looks. So negative 2 and up 1, 0 and up 4, 1 and negative 1, 2 and negative 5, down here, and then 3 and negative 2. So it's some sort of shape like so. Let's try a few more examples. So I think the graphs are the same. The question is different. We're looking to do now a composition and do a sketch. So what we're going to do is, again, think of this as g of f of x. So we're going to go through all the inputs of x inside of f, find that output, and then find the output once the g is applied as well. So at first I'll do it one step at a time. The very first x I'm going to consider is negative 3. So negative 3 inside of function f gives me an output of 1. So negative 3 under function f gives me 1. Then I need to apply function g. So to apply function g, you consider 1 as the input now, not the negative 3. The 1 is the brand new input inside of function g. So 1, the output is read from the graph, negative 1. So when you're recording your point, you want to start with the input. Your final output is the y value of the point. So I'll do the next one. So I'm just going to go through the list of points here from left to right. So all these red points of the function f. The next one would be negative 2. So same idea, negative 2 under function f gives me a negative 1. And negative 1 under function g gives me positive 3. So you start with negative 2, you end with 3. Okay, the other ones I'll do a little bit faster and then I'll do a sketch. So the next point is negative 1, comma. So at negative 1, output is negative 3. Negative 3 in G is an output of negative 2. 0 is the next one. At 0, F output gives you negative 2. And negative 2, the output is 0. Next point is 1. So 1 gives you an output of 0. And 0 gives you an output of 2. Then 2. 2 gives you an output of 2. And 2 under G gives you an output of negative 3. And the last one, if you start with 3 as an input inside of F, the output is 3. And so 3 as an input inside of G, an output is 1. And so if you plot these, you'll have a rough shape of the composition. So negative 3, negative 1, negative 2, up 3, negative 1, down 2, 0, 0, 1 and 2, 2 and negative 3, and 3 with 1. So it's some sort of shape like so.